Hi, welcome once again to the Varanyas Photon Online Educational Academy for IIT and NEET examinations. This is Guntuka Srinivas. In this channel, we mainly concentrate on the basic concepts associated with physics, chemistry, and mathematics subjects related to the IIT and NEET examinations. I welcome you all for the IIT physics classes. If you like the video, please share it and subscribe the channel. In the previous session, we have seen some numericals related to velocity, especially displacement versus time. Let us see some more numericals associated with that concept. Let me take up the first problem, that is ST graph, displacement versus time graph. ST graph is given below. Find VT graph from the above. Given ST graph. This is the question. Observe carefully. He has given the ST graph. Displacement versus time graph is given. Now he is asking us from that graph, he is asking us velocity versus time graph, VT graph. Yeah. And graph is provided here. This is the graph. This is x-axis. This is y-axis, origin. On the x-axis, time, t, in seconds. On the y-axis, displacement, S in meters, S in the meters given. And the line provided is, this is the line, straight line falling down. And here, on the y-axis, 10 meters given. On the x-axis, 5 seconds given. This is the graph associated. On the x-axis, time in seconds. On the y-axis, yes, displacement in the meters. Clear? A straight line falling down with 10 meters on the y-axis and 5 seconds on the x-axis is provided to us. Clear? He has given some options also in this question. Let us see the options. First option he has given option, that is, this is the graph, first graph, x-axis, y-axis, velocity is on y-axis, time is on the x-axis, and graph is a straight line parallel to the x-axis, and at this point 2 meter per second. This velocity is in the meter per second, and this time is in seconds. Time is in the seconds. Here, this is the first option. The second option he has given, that is the B option. This is the x-axis. This is y-axis. On x-axis, time t in seconds. On y-axis, velocity in the meter per second. This is origin. Clear? Now, the graph provided here is a straight line passing through origin. And this is dotted lines showing 2 meter per second velocity given. Clear? That is the option B. Now, coming to the option C. Option C is given. This is x-axis, y-axis, origin, time in seconds, velocity v in meter per second. Clear? Meter per second. And observe, there is a line. There is a line going down like this. Going down like this. Okay. And here, this is dotted lines. Velocity is 2 meters. Velocity is 2 meters per second. Given. Clear? That was the option. That was the option. Let us see the fourth option. D option. This is the x-axis, y-axis. Here, origin. T in seconds on x-axis. And v in velocity in meter per second on the y-axis. Clear? Now, graph is provided. This is the graph. And graph is straight line parallel to x-axis. But here it is -2. -2. Here also it is minus. In the C bit also minus. Towards negative y-axis. Both C and D are towards negative y-axis. These are the 4 options that are provided to us. In the first option, the velocity is positive, 2 meters per second. In the second option, velocity is positive, 2 meters per second. In the third option, the velocity is negative, -2 meters per second. And in the fourth option, the velocity is again negative, -2 meters per second. And be careful, this is with a constant velocity. As the time is passing, 1 second, 2 seconds, 3 seconds, velocity same, constant velocity, 2 meters per second. Clear? So, have the clarity in the option. Before going into the problem, have the clarity. First option says 2 meters per second velocity, positive velocity, constant velocity. As the time is passing, constant velocity, but positive velocity. Whereas in the second option, velocity is 2 meters per second here. Here it is 2 meters per second. Okay. But observe velocity as time is passing. 1 second, there is a difference. 2 seconds, there is a difference. Like that, as time is passing, there is a velocity change. Velocity is change. Here, similarly in the third option, okay, velocity is completely changing with respect to time, velocity is negative. But in fourth option, velocity is negative. As time is passing, velocity remaining constant. Clear? Now let us go to the solution of the problem. Solution of the what is the given graph? Given ST graph. We are provided with given displacement time graph. Let us see, let us analyze the given graph. This is x-axis, this is y-axis, this is R, is it? And the x-axis time in second, on the y-axis displacement in meters, displacement in the meters. Clear? Now, what was the graph? Straight line. Here it is 5 seconds. Here it is 10. Okay. Now, from the displacement time graph, you have to find out velocity time graph. How the clarity? What is asking? From the displacement time graph, given is displacement time graph, you are required to find out velocity time graph. Clear? Now, let us analyze first this graph. Here, let us analyze the graph. Observe, if we observe, this is a straight line falling down. This is a straight line falling. Now, what is the conclusion that we get? The slope of displacement time graph, S versus T graph, the slope of displacement time graph is velocity. This is our conclusion from the previous sessions. We have seen that the slope of displacement time graph is nothing but the velocity. Clear? Now let us analyze the slope first. Let us analyze the slope. Observe, if this line is making an angle theta with respect to positive x-axis. Observe, this is the positive x-axis. We are always taking positive x-axis. The line, the falling line, like this, the line is falling down, and that line is making angle theta with respect to positive x-axis. And this theta is more than 90 degrees. Okay, theta, observe, theta is more than 90 degrees with respect to positive x-axis. The first conclusion. What is the first conclusion from the graph? The line is a falling line, and theta is more than 90, greater than 90 with respect to positive x-axis. Whenever theta is more than 90, slope is what? Tan theta. If theta is more than 90, tan theta is always negative. That means the slope is always negative. For the falling line, the slope is always negative. In the previous class, we have seen for the falling line, the slope is always negative. Second conclusion is slope is negative. Slope is negative. Once the slope is negative, what is the slope of displacement time graph? Velocity. Clear? Once the slope is negative means velocity is always negative. The third conclusion is velocity. Since slope is negative, velocity is negative. Velocity is negative. See how we got all the conclusions from observation of the graph. So given is a displacement time graph. So it is a straight line falling down. So What does the slope of displacement time graph gives? It gives velocity. It gives velocity. Clear? Now observe, the line is making a theta angle with respect to positive x-axis, always positive x-axis, more than 90. When theta is more than 90, slope is tangent of theta, tan theta. Tan theta is always for more than 90 degrees, tan theta is always negative. Slope is negative. When slope is negative, falling line, slope is always negative. You can get a conclusion like that also. Falling down, slope is negative. When slope is negative, automatically the slope of that graph is nothing but velocity. Velocity is negative. Velocity is negative. These are the three conclusions. Clear? Now, observe here. When you take the slope, if I take the slope here, this is the theta. If I take the slope here, clear, this is the theta. If I take the slope here, this is the complete theta. That means whatever the parallel lines I draw, theta is always constant. That means slope is constant. When the slope is constant, velocity is also constant. So fourth conclusion here I put up that since theta is constant, okay, this is, observe carefully, since theta is constant, velocity is constant. Okay, look at this. Velocity is constant. Now theta, parallel lines, all this theta is constant. So as theta is constant, velocity is also constant. So from these four conclusions, now we can plot the velocity versus time. Observe. So this is the given graph. This is the given graph. X-axis, origin, y-axis, S, T, and graph is like this, falling down. So graph is like this. That is the falling line. Now this is 10, this is 5, this is 5. Now what is slope? Slope is y2 minus y1 by x2 minus x1. Now, if I say this is here point one is the point, let us say A, let us say B, let us say B. What are the coordinates of this A? Coordinates of this A, x coordinate 0, y coordinate 10. What are the coordinates of B? X coordinate is 5 here to here, y coordinate is 0. So if I say this is x1, if I say this is x1 comma y1, if I say this is x2 comma y2, now the slope here is y2 minus y1, 0 minus 10 by x2, 5 minus 0. So it becomes minus 10 by 5, minus 10 by 5. This becomes minus 2. So velocity, slope of S versus T graph is velocity. Velocity V bar, vector quantity, is minus 2. This is in the meters. This is in the seconds. So unit is meter per second. So quantity of velocity is negative velocity we got, and that too minus 2 meter per second. Clear? Units are meters per second. Okay. Now quantity also we got. Now we arrive at the graph, final graph. What does it require? Velocity time graph. So origin on the x-axis, time t in seconds, time t in the seconds. This is the y-axis. And on the y-axis, velocity in meter per second. We are plotting the velocity time graph from the data of displacement time graph. Clear? What was the quantity, velocity, how much we got? P bar quantity, we got minus 2 meter per second. This is the quantity. It is negative. So I put up, this is the positive y-axis. This is the negative side of y-axis. So negative side, minus 2 meter per second. This I mark. Velocity is on the y-axis. This is upward is positive velocity, downward is negative. So velocity is negative. So downward I have to indicate, downward minus 2. Here I have indicated. Okay. And from the previous conclusions, what is the velocity? Velocity is constant. As theta is constant, velocity is constant. So this is the constant parallel line. A parallel line, the x-axis, constant. As time is 1 second, 2 second, 3 second, velocity same, minus 2, minus 2, minus 2. Constant velocity. This is the graph. From the above conclusion, look at the options. Which option is correct? So from the all the conclusions, option D is correct. Option D is correct. This is the way how you have to analyze the given displacement time graph from the analysis of the slope, velocity, etc. And you can calculate the quantity y2 minus y1 by x2 minus x1, velocity, the slope. Then you put the units, whatever the given units here. Then you plot taking velocity on y-axis, displace time on the x-axis. How we opt. Clear? Let me take up the second question. This is the second question. We are going for the second question. The position of an object, the position of an object moving along x-axis, is given by x is equal to a plus b t square, a plus b into t square, where a is equal to 8.5 meters, comma, b is equal to 2.5 meters, per second square. Observe carefully, units are different. A is 8.5 meters, B is 2.5 meter per second square. Time t is measured in seconds. Time t is measured in the seconds. Now, is asking what is its velocity? What is its velocity at t is equal to 0 seconds and at t is equal to 2 seconds. T is equal to 2 seconds. Here, T is equal to 2 seconds. Okay. Observe carefully the problem. Position of an object moving along x-axis. Object is moving along the x-axis, and the movement is given by this mathematical expression. X is equal to a plus b t square. This one term, b into t square. This is the mathematical expression where a is 8.5 meters, b is 2.5 meter per second square. Time t is given in the seconds. Now he is asking, what is the velocity at a particular time t is equal to 0? Velocity at t is equal to 2 seconds. That was his question. Clear? Object is moving along x-axis. Means displacement is along the x-axis. That's what? It is displacement equation only. Left-hand side x is displacement. Right-hand side dimensionally it is a fit equation. A is in the meters, B is in the meter per second square, and this is second square t square. Second square goes out. So B comes completely, this entire term comes meter. So already A is in meters. Dimensional homogeneity is maintained by this equation. A is in meters, B into t square term is also in the meters. So meters plus meters completely. Entire right hand side is meters. Left hand side x is meters. It is a displacement versus time equation is provided. In the previous session, we have seen the same equation in terms of S versus T. In place of S, we are noticing here X. Time is in EOT. There is no change in the notation. Clear? So S is equal to A plus B T square. Like that, that was the equation. But since object is moving along x-axis, so in place of S notation, he has provided as X. Displacement is along x-axis. Clear? So this was the problem. This is the first problem as asked. The extension of this problem, also given. Clear? The extension of this problem is what is average velocity between t is equal to 2 seconds and t is equal to 4 seconds. This is extension of this problem. Here he is asking average velocity between t is equal to 2 and t is equal to 4. Here, now let us solve this problem. Okay, now let us see what is the given equation. Mathematical equation is x is equal to a plus b into t square. This is the mathematical equation given. Now I am plotting. This is the x-axis. This is x direction. X direction. Yeah, x direction. So this is x. Everything is arrow mark indicates x in meters. Displacement in the meters. Arrow mark indicates displacement in the meters x direction. Clear? Let us say origin. This is the origin starting point. Object is moving along x-axis. Clear? Expression is displacement is x and a, b are given to you t, the time. As time is passing, as time I clearly write. As as time as time t passes, as time t passes. Clear? It is displacement is going in the x direction. Okay, that is the conclusion. Now, observe what he says. He requires when the time t is equal to 0, when time t is equal to 0, what is the velocity? At a particular time t is equal to 0, what is the velocity? Okay. Similarly, at the time t is equal to 2 seconds, at a time t is equal to 2 seconds, what is the velocity? At a particular instant is asked. Okay. Now, at a particular instant is asking, hence it is instantaneous velocity. What is the instantaneous velocity? V bar vector instantaneous is d, s by dt. Since displacement in place of s provided x, so here it is dx by dt, dx by dt, because equation is given in the terms of the x. General terminology is yes, but equation is given in terms of x. So in place of yes, we are following x. Clear? Now, what is the equation given? That is, given equation is x is equal to a plus b t square. So v bar is dx v instant, and yes, dx by dt, which is equal to constant a. Differentiation of constant is 0. So 0 plus b constant into differentiation of 2t. Everything is with respect to time t. T square differentiation is 2 into t. 2 into t. Clear? 2 into t. Now, v instantaneous velocity. Nothing but I'm directly writing this 2 b into t. 2b. 2 b value is given. What is the b value is given? 2.5 meter per second. T is at what time it requires? At what time it requires? At clearly at t is equal to 0. At t is equal to 0, substitute here 0. So velocity is completely 0 meter per second. 0 meter per second. That is the first. Here, velocity is 0 meter per second. At t is equal to 0. At t is equal to 0. Clear? The equation itself is 2 into b into t. This is 2 into b into t. So from this 2 into b into t, if I substitute the values, automatically velocity. Let us take up the second one. V bar velocity vector, bar indicates vector, at time t is equal to 2 seconds, which is 2 into b into t. 2 into b into t. Okay, 2 into b is how much? 2.5 into time. Substitute this value, 2 seconds. Okay. Then finally it becomes 10 meter per second. In simplification, 10 meter per second. So instantaneous velocity at time t is equal to 2 is nothing but at time t is equal to 2 is nothing but 10 meter per second. Clear? The first part of the problem is over. At t is equal to 0, we got 0 velocity. At t is equal to 2 seconds, we got 10 meter per second. Let us go into the second part of the problem. Okay, what is asking in the second part? Average velocity. Second part here. Average velocity. Average velocity. Okay, between t is equal to 2 seconds and time t is equal to 4 seconds. This is in between 2 seconds and 4 seconds. It equals average velocity. What is the average velocity formula? The average velocity V bar is V average EV, change in displacement by change in time, or completely total displacement within the given time periods, that is 2 seconds and 4 seconds, divided by total time, that in between 2 and 4 seconds. Total displacement in between 2 and 4 seconds divided by total time in between 2 and 4 seconds. That is the one formula, or simply change in displacement, like change in time. Okay. Now, in place of s, can I write like this? Because equation is in terms of x, dx by s. In place of s, we have x, dx by dt. Change in displacement, x2 minus x1 divided by t2 minus t1. T2 minus t. Clear? What is x2 here? What is x2 here? x2 is displacement. x2 is displacement at t2 seconds. t2 seconds. Okay, t2 is what? 4 seconds. t2 is 4 seconds. Similarly, what is x1? x1 is displacement at t1 seconds. t1 second. What is t1? 2 seconds. 2 seconds. If I denote the first one as t1, the second one as t2. So t2 is 4 seconds and t1 is 2 seconds. x2 stands for displacement at 4 seconds. x1 stands for displacement at 2 seconds. Clear? Now, observe. Displacement equation, x is a plus b into t square. This is the equation. Okay. Now, x2 I need. x2 is equal to, x2 is a plus b. At what time? At what time x2? 4 seconds. So 4 square. 4 square. Okay, here I clearly write x2 at t2. t2 is 4 seconds. So in place of t, I put up the 4 seconds. So observe, this one is equal to, a is what? A is given 8.5 meters plus b is what? 2.5 and 4 square. 4 square is 16. 15. And that becomes, okay, on simplification, how much it is? So 8.5, 2.5. So 8.5 plus 16 5s are 80. So it becomes 40 meters. Completely, totally it becomes 40. Total it becomes 48.5 meters. X2. Yeah. Similarly, I require x1. x1 is equal to a plus b. At what time x1? Again, I write here. Time I write at t1, 2 seconds. x1 is displacement at t1 seconds. And that here, if I substitute 2 in place of time, 2 square. So A is 8.5 plus B 2.5 given into 4. Okay. So this becomes 8.5 plus this becomes 10. 18.5 meters. 18.5 meters. Okay. Now I substitute the values. So V average x2 minus x1 by T2 minus T1. T2 minus T1. Yeah. This becomes x2 48.5 meters minus 18.5 meters by T2. T2 is how much? 4 seconds. T1 is 2 seconds. So V average becomes, this becomes 30 by 2. So this is 15 meter per second. 15 meter per second is the average velocity. Average velocity in between t is equal to 2 seconds and t is equal to 4 seconds. Here, so in the first step, first part of the problem, we calculated instantaneous velocity at a particular given time. T is equal to 0 and t is equal to 2 seconds. A particular instant of time. Whereas in the second step, in the second part of the problem, we have calculated average velocity. Average velocity in between t is equal to 2 seconds and 4 seconds. Then change in displacement in between these 2 points. T is equal to 2 seconds and 4 seconds divided by change in time in between these t is equal to 2 seconds and 4 seconds. That is nothing but this. Is it clear? Oh, you have understood the problems. As I have explained in detail, go through these problems once again. Slowly, you practice the time limit also. Here, I am explaining without the time limit because your understanding the concept is very important. That's why in detailed manner, I am explaining. But the same problem if appears in the examination, you should be able to do it within a fraction of seconds. That is your motive. Just practice, practice. That's all. Without pen and paper, just in the mind only, you should get the answer. Is it clear? Thank you very much. And if you like the video, please share it and subscribe the channel. Thank you very much.